In this problem, we're asked to determine whether B is the inverse matrix of A. So it would be helpful to review the definition of an inverse matrix, which I've put over here to the right. So for any n by n matrix, so it has to be a square matrix, A. If there is an inverse matrix for A, then if I find the product of A inverse with A, it's going to give me the identity matrix for that square, which would be a 1 on the diagonals for the n by n matrix and 0 everywhere else. And also, it has to be commutative. So if I do A times A inverse, that also has to give me that identity matrix. So we're going to multiply these matrices, and as you know, I'm not a fan of calculators because you need to understand how the operation of multiplication works. Then, as you go on and work with bigger matrices, it's fine to use technology to multiply those. But when you get started, it's not a bad idea to know how to work the problems by hand. So I'm going to start multiplying these by hand. If B is the inverse of A, then if I multiply A times B, I should get the identity matrix. So when I multiply to get the first element in the first row or column up here, I'm going to multiply the elements across this matrix with the column down this matrix. And I'm going to do 3 separate multiplications and add them together to get that one element. So negative 1 times 56, the first here times the first here, that's negative 56. Then I'm going to go across and take this negative 1 and go down this column. Negative 1 times 42 would be a positive 42. And then negative 1 times negative 15 would be a positive 15. And just because here I don't have to find the whole product, I'm interested in knowing whether or not I'm going to get this diagonal matrix 1 0 0 0 1 0 0 0 1, then I'm going to go ahead and mentally compute these sums, because anytime I don't get a 1 or a 0 where I need it, then I don't have to finish. So negative 56 plus 42 plus 15, that would be 1, and I need a 1 there. So I'm going to continue with the next element in the matrix. So to get row 1, column 2, I'm going to use row 1 of the first matrix and go down column 2 of the second matrix. So I'm going to start with this negative 1 again, only this time I'm going to use column 2 because I'm trying to find the element here in column 2 of the product. So negative 1 times 19, that's negative 19. And then I'm going to add the next product, which I get from the second item in this first row and the second item in the second column, because I'm trying to find an element in row 1, column 2 of my product. So negative 1 times negative 14 is positive 14. And continuing on, the third element in the row times the third element in the column, negative 1 times 5 would be plus a negative 5 or minus 5, whichever way you want to do that. And again, checking, I need this to come out to 0. And it doesn't. When I add these, I get a negative 19 plus 14, which is negative 5 plus negative 5, and I get negative 10 instead of 0. Now, since the sign, a difference in sign would have made this correct, let me double check my arithmetic. So negative 1 times negative 19, negative 1 times negative 14 is positive 14, and negative 1 times negative 5 is negative 5. So I didn't make any arithmetic mistakes, and I can quit because I should get a 0 there if those two matrices are indeed inverses.